Okay, let us now discuss question number 25th from the practice sheet. Question number 25th says, let A be one point of intersection of two intersecting circles with centers O and Q. The tangents at A to the two circles meet the circles again at B and C respectively. Let the point P be located so that AOPQ is a parallelogram. Prove that P is the circumcenter of triangle ABC. Okay, so this question is very long question. Okay, it might look horrible in first look. So what we will going to do, we will going to again break this question into smaller parts and try to understand each and every line. So let us read the first line. First line says that let A be one point of intersection of two intersecting circles with center O and Q. So question number 25, it says A is a point at which the two circles intersect. The two circles are with center O and Q. So let us first draw two circles. Let us say this is one circle and okay, it might look like circle. Let us say this is a circle and this is another circle. So the centers of the two circles are O and Q. And these two circles, obviously when two circles intersect each other, they will intersect at two different points. This is one point and this is another point. So let us say this point is point A. It says that two circles with center O and Q intersect each other at two different points, but one of the points of intersection is point A. After that it says the tangents at A to the two circles. Okay, so at point A, since A point lies on both the circles with center O as well as on the circle with center Q. So what you need to do is you need to draw tangents to the two circles, and the tangents meet at points B and C respectively. It means if I draw a tangent at this point A to this green circle, it will be something like this. This is the tangent to the circle, and this tangent meets this pink circle at point B. Okay, this tangent meets this circle at point B. Similarly, if I draw a tangent to this pink circle, it will meet this green circle at point C. Okay, this is what is given. This particular tangent meet this circle at point C. After that it says let the point P be located so that AOPQ is a parallelogram. So AOPQ, now you have 3 points here. One is A, O and then Q, and one you need to locate the point P such that AOPQ forms a parallelogram. So what you need to do is first join this A and O. Okay, after that join this A and Q. Now you need to draw a parallelogram using these two sides. How to draw parallelogram using these two sides? Draw a line parallel to this AQ passing from this O point. Okay, what I am saying is if you want to draw a parallelogram using this A, O and Q points and one more point P, So to locate the point P, to determine the position of point B, what we will going to do is point P, we will draw a line parallel to this AQ passing from this O point. So we will draw a line parallel to this AQ passing from this O point, something like this. Okay. After that, we will draw a line which is parallel to this AO and passing from this Q point. So something like this. This will be the line. You can assume that this is a parallel line. This line is parallel to AO, and the point at which these two lines intersect is basically point P. Okay, and it is given AOPQ is parallelogram. Since AOPQ is parallelogram, I can say AO is parallel to PQ and AQ is parallel to OP. This is what is the condition for parallelogram. This is what is the property of a parallelogram. Okay. So after this, prove that. So till this point the given conditions are over. Now we need to understand what we need to prove. So we have understood the diagram. The diagram says there are two circles, one with center O and another with center Q. These two circles intersect at one point A. Okay. At this point I have drawn two tangents to this two different circles. One tangent is AB and another tangent is AC. After that it says A, O and Q are the 3 points, and these 3 points form a parallelogram with one more point P. So we need to locate the point P. So how do we have located point P? We have drawn a line parallel to AQ which is passing from O, and we have drawn a line which is parallel to AO and passing from this point Q. So this is the location of point P. Okay, it might not look like a parallelogram exactly because I have drawn it on a board. So you can draw this in your notebook with proper compass and ruler. So this is the location of point P. This is what we have understood. After that it says prove that point P is the circumcenter of triangle ABC. Now what is meant by circumcenter? If you do not know the definition of circumcenter, the meaning of circumcenter, you will not be able to solve this question. So first let us understand what is circumcenter. Circumcenter, its definition is very simple. It is the point of concurrence of perpendicular bisectors. Okay, circumcenter of any triangle is defined as the point of concurrence of perpendicular bisectors. Now, so if I have a triangle like this is ABC, this is a triangle, and if I draw perpendicular bisectors on the 3 sides of this triangle, the 3 perpendicular bisectors will look something like this. Like this. These are the 3 perpendicular bisector. This, let us say this point is O, this is A, no, this is P, Q, R. If I draw a perpendicular bisector PO which is bisecting AB side and it is perpendicular to this side also. If I draw QO which is a perpendicular bisector of AC, and if I draw this OR which is perpendicular bisector of this BC, these 3 perpendicular bisectors will meet at a single point. This will happen in each and every triangle. अगर किसी ट्राइंगल में तीनों परपेंडिकुलर बाइसेक्टर एक पॉइंट पे मीट नहीं कर रहे, इसका मतलब ट्राइंगल गलत बना हुआ है. आपने परपेंडिकुलर बाइसेक्टर बनाने में कुछ ना कुछ गलती की है. अदरवाइज हमेशा ऐसा होगा कि जब मैं तीनों साइड्स पे परपेंडिकुलर बाइसेक्टर बनाऊंगा, दे ऑल विल मीट एट अ सिंगल पॉइंट and this point O will be known as the circumcenter of this triangle. Now why it is known as the circumcenter? Circumcenter is basically is a center of a circle which circumscribes this triangle. What does I mean to say is, if you keep your compass here and if you take this much radius up to this point C, and if you draw a circle using this particular radius, you will find that there will be a circle which circumscribes this particular triangle whose center is this point O. So circumcenter is the center of a circle which circumscribes the given triangle. Okay, so here I can write this, its center of circle which circumscribes the triangle. It basically circumscribes the triangle. That's why it is known as the circumcenter, that is center of the circumcircle. Okay, so this is the definition of circumcenter. Now coming back to this question, if I want to prove that this P point is basically the circumcenter of triangle AP, this ABC, this AB, and if you join this with C point, this is ABC, ABC triangle, then what exactly you need to prove? अगर मुझे P point को circumcenter बताना है, मतलब मुझे ये प्रूव करना है that P point is basically the point of intersection of perpendicular bisectors. So if somehow I prove that P is the point of intersection of perpendicular bisectors, then I can very easily say that P is the circumcenter of this triangle. Okay, so let us try to prove this. Let us try to prove that P is the intersection of perpendicular bisectors. Now observe this diagram very carefully. If you observe this AO, AO is basically the radius of this circle, okay, and AC is the tangent to this circle. AC is tangent to the circle, AC is tangent, and AO is radius. If AC is tangent and AO is radius, I can write AO is perpendicular to AC by theorem 1. According to theorem 1, this AO is the radius and it is perpendicular to, it is touching the tangent at the point of contact. So this AO is perpendicular to AC. It means this particular angle is 90 degree. That is this blue line and this orange line. Okay, not with this blue line and this orange line. This AC, not AQ. I am talking about AO, this line, and AC, this line. Okay, so these two lines are perpendicular to each other. Now since this AO is parallel to PQ, since AO is parallel to PQ, why? Because this AO PQ is a parallelogram, so AO is parallel to PQ. This implies PQ is also perpendicular to AC. Can I say this? Yes, because you can see this AO line, this is perpendicular to AC and this PQ line is parallel to AO. So what about this angle? This angle is also equal to 90 degree. Why? You can say that this and this are corresponding angles because we have two parallel lines. These are the two parallel lines and this AC is a transversal for these two parallel lines. So this angle will be equal to 90 degree. So it implies angle PQC is equals to 90 degrees. Okay, angle PQC. So this angle is 90 degree. Now what is Q? Point Q is the center of this circle. And what is AC? AC is basically a chord of this circle. You can see AC is a chord of circle with center Q. AC is the chord of circle with center Q. जिस सर्कल का सेंटर Q है उसके लिए AC क्या है? एक chord है. AC is tangent to this circle but chord for this circle, and you can see Q. Sorry, this is not point Q. This is, let us say, we mark this point as, let us say this point is L, this particular point. So angle PLC. Angle PLC is equals to 90 degree. So you can see Q is the center of the circle and QL is perpendicular to AC. QL side, this QL length, this very small length is perpendicular to this AC. So I can say this implies AL is equals to LC. What I have written, I have said that AC is the chord of this circle, QL is the radius, QL is a perpendicular from this center Q to this chord L, this AC. That's why AL is equals to AC. And what is the reason for this? The reason is perpendicular from the center to a chord bisects the chord. Okay, perpendicular from the center to a chord bisects the chord. It means this QL bisects this AC. Okay, QL is bisecting this AC. QL is bisecting, or I can say this PQ line is basically a perpendicular bisector on AC. Okay, so this implies PQ is perpendicular bisector of AC. Okay, now similarly if you observe this line AQ is basically radius of this circle and AB is a tangent to this circle. So AQ is radius and AB is tangent. AQ is radius and AB is tangent. It implies AQ is, or I can say that this is not AQ. Yes, this one, this AQ, I can say that AQ is perpendicular to AB. Okay, why? Because AQ is the radius of this circle and AB is a tangent to this particular circle. That's why AQ is perpendicular to AB. Okay, now if you observe this condition, since AQ is parallel to which line? This OP line. So AQ is parallel to OP, I can say that OP is also perpendicular to AB. Okay, this OP is perpendicular to AB, it means this angle is 90 degrees. And let us say the point at which this OP line intersects this AB is, let us say, M. Okay, M is what? M is basically point of intersection of point of intersection of OP and AB. And what about L? L is point of intersection of this AC and PQ. Okay, PQ and AC. This is L and this is M. So if OP is perpendicular to AB, what is AB? AB is the chord of circle. AB is a chord of circle with center O. As you have seen, AC is tangent to this circle but chord for this circle. Similarly, AB line is tangent to this circle but chord for this circle. Okay, so this AB is a chord for this circle and this OM is perpendicular to AB. So what I can say is OM perpendicular to AB, it implies AM is equals to MB. Okay, so what you can see, this M is the midpoint of this AB, just like this L is the midpoint of this AC, that is L is bisecting this AC line. Similarly, this point M bisects this AB line. Now you can see OM is perpendicular to AB as well as OM bisects AB. So what is OM? I can say OM or OQ is this OM or OP is perpendicular bisector of AB. Okay, I can say OP is perpendicular bisector of AB. Now observe the two conditions. You have written first that PQ is perpendicular bisector of AC and OP is perpendicular bisector of AB. So these two perpendicular bisectors meet at point P. So what is P point? P point is basically the intersection of two perpendicular bisectors of a triangle. It means P point is, since P is point of intersection of perpendicular bisectors of AB and AC, it implies P is circumcenter. P is definitely a circumcenter. Okay, in this way we can prove that this P point is the circumcenter. Now what about BC? You don't require BC. Okay, हमें दो किसी भी perpendicular bisectors को लेके intersection point निकालना था, because इस triangle में अगर BC का भी हम perpendicular bisector बनाएंगे, so that should pass from this P point. अगर वो P point से pass नहीं हो रहा, it means आपने perpendicular bisector बनाने में गलती करी है. Okay, because if you see, if I rub this particular perpendicular bisectors, the two perpendicular bisectors of this AB and AC will again meet at point O. अगर मैं किसी भी दो sides पे perpendicular bisector बनाता हूँ, तो they should meet at the circumcenter. So in this case, by reducing the perpendicular bisectors of these two sides, okay, AB and AC, we have proved that we have sufficient proof that so that we can say that this P is the circumcenter. Okay, so this condition implies P is the circumcenter. So this is how you need to solve question number 25. It's a very tricky question, it's a very confusing question, because you have two different circles with different centers, but the conditions are applied on both the circles are same. Okay, so this is the solution for question number 25. Note this, then we will continue. Okay, now let us solve question number 26 from the practice sheet. Question number 26 says, find the locus of centers of circles which touch a given line at a given point. Okay. So what is meant by locus? Locus means the path. You need to trace the path of the centers of the circles which touch a given line at a given point. So this question says, question number 26, let us suppose there is a line. Let us suppose this is a line, and on this line there is a point P. You need to determine the locus of centers of the circles which touches this particular point. On it says find the locus of centers of the circles which touches a given line. So let us say this is a given line and at a given point. So let us say P is the given point. Okay, let this L is the given line and this P is a given point, and I have to draw circles such that the circles touches this point P, this particular point P. So how to draw circles which touch this particular point P? Let a circle is something like this. This is a circle which touches this point P. In similar manner, can I draw one more circle like this? This is also a circle which touches this particular point P. Again in similar manner, can I draw one more circle like this? This circle is also touching this particular point P, and one more circle like this which touches this given point P. After this I can draw one more circle like this. This circle also touches this particular point P, and this circle also touches the point P. But what about the centers of this circle? Let us say the center of this first circle, this small circle, is O1. Okay, let us say the center of this larger circle is somewhere here, which is O2. Okay, and center of this largest circle is, let us say, somewhere here, which is O3, and center of this smaller circle is, let us say, O4. Center of this yellow circle is, let us say, O5, and center of this largest circle, blue circle, is, let us say, O6. Now these are what? These are the centers of this 6 circles. This P is a point of contact of these circles and this line L. So can I say, if I draw a perpendicular from this O1 to this, a line from this O1 to this P point, this O1P will be perpendicular to L. Can I say this condition? O1P is perpendicular to L. Similarly, can I say O2P is also perpendicular to L? Because if I join this O2 to this P point, this O2P will be the radius of this circle, and P is a point of contact of this circle and this particular line, particular tangent. Similarly, what about this circle? The center of this circle is O4. Okay, and this circle, if I join this O4 and P, this O4P is the radius of the smaller circle, and P is the point of contact of this circle and the tangent. So can I say O4P is perpendicular to L? Similarly, O5P is also perpendicular to L, and similarly O3P is perpendicular to L, and O6P is perpendicular to L, because O5P, O6P and O6, this P, because all these lines are radius of the circles, are the radii of 6 circles. Now can I draw more circles at this particular point? Yes, I can draw infinite circles which are passing from this P point. Okay, I have drawn 6 circles only till now. Now you can see that at this particular point, all these points, the line drawn from all these 6 points are perpendicular to this line L at a single point, at this P point, this P particular point. So can I have multiple perpendiculars at a single point? No, I cannot have multiple perpendiculars at a single point. So what does this mean? It means that if I join all these points O3, O2, O1, P, O4, O5 and O6, all these points will lie on a straight line. Okay, all these points will lie on a straight line. So I can say since only one perpendicular can be drawn at point P, it implies O1, O2, O3, O6 up to ON all lie on same line. All these points lie on same line. It means that locus of all centers are, or locus of all the centers is a straight line. Okay, what I have said, if I draw 6 circles or infinite circles like this, thus the line from the center of the circle and the line joining the center of the circle and point of contact will always be perpendicular to this particular line L. But at this single P point, I cannot have multiple perpendiculars. Hence, I will say that all these perpendiculars lie on the same line, because at single point P, I can have only one perpendicular. That's why, since all these points lie on the same line, the locus of centers of the circle which passes from this point, which touches this point, is a straight line. Because you can see, if I draw more circles, their centers will lie on this particular line only. Okay, they cannot lie anywhere near this line, they have to lie on this line, then only the circles can touch this P point, otherwise they will not be able to touch this P point. Okay, they may intersect this P point. Okay, you may draw a circle which is something like this, but this is not considered because it is passing from P point, but I want those circles only which touches this particular P point. Okay, so in this way, the locus of centers of the circle which touches a given line at a given point is a straight line. So this is the solution for question number 26. This question is very logical question. First you need to understand the meaning of locus, then only you will be able to solve this question. Okay. Now after this, let us discuss question number 27 from the practice sheet. Question number 27 says, in figure, common tangents AB and CD to two circles with centers O and O dash intersect in E. Prove that the points O, E and O dash are collinear. Okay, so first let us draw the diagram of this question. Question number 27, it says that there are two circles. This is one circle and this is another circle, and we have two tangents drawn to this circle. Now what is a common tangent? A tangent which is tangent to this circle as well as to another circle, something like this. Okay, it is tangent to this particular circle also. This is a circle and this tangent is AB. So what you can see, this AB is a tangent to this circle as well as to this circle. It is a tangent to this circle at this A point and tangent to this circle at this B point. Okay. After that, there is one more tangent. We will understand the concept of common tangent. First, let us solve this question, then we will understand the concept. Now, at this point, I have drawn one more tangent like this, like this. Let us say these are two circles. Another tangent, it is tangent at this point C and tangent at this point D. Okay. Then the intersection of these two tangents is point E. The center of this circle is given as O and the center of this circle is O dash. So let us join this O point with this E point and this E point with this O point, O dash point. Okay, this is the figure given in the question. Now it says in figure common tangents AB and CD. So AB is a common tangent. Why? Because it touches this circle as well as this circle. Hence we call this AB as a common tangent. And CD is also a common tangent. These two tangents intersect at point E. Okay, intersect in point E. Prove that O, E and E dash are collinear. What you need to prove is O, E and O dash are collinear points. Okay. What is meant by collinear? Collinear means that these 3 points lie on the same straight line. It means if I want to prove that O, E and E dash are collinear, simply what I need to prove is that O, E and E dash form a straight line. I just need to prove that this line is a straight line. If somehow I prove that this line is a straight line, I can say that O, E and O dash lie on a straight line, or O, E and O dash are collinear. Okay. So let us try to prove this. First thing to observe is that this is an external point E. I can see that EA and EC are tangents to this circle with center O. Okay. This EA and EC are tangents to this particular circle. What I can say is EA and EC are tangents to the circle with center O. Okay. So if EA and EC are tangents to this circle, I can say that this angle and this angle are equal. What I can say is this particular angle and this particular angle are equal. I can say angle AEO is equals to angle CEO. Why this property I have written? Because we have initially proved that OE is an angle bisector of angle AEC. Okay, OE is what? OE, this OE line is basically an angle bisector of angle AEC. AEC angle, it is an angle bisector of angle AEC. That's why these two angles are equal. Let us say this angle is X and this angle is also X. Okay, because both the angles are equal. Now, similarly, if you observe ED and EB are tangents to the circle with center, tangents to the circle with center O dash. Okay, EB and ED are tangents to the circle. This is a circle with center O dash. EB and ED are tangents. So if EB and ED are tangents, again I can write angle DEO is equals to angle BEO. Why this condition? Because EO dash is an angle bisector of angle DEB. Okay, I am not writing the complete property, I am not proving that angle x and this angle are equal, because we have already proved this condition. You should remember what we have proved in a question, that this OE dash, this line is a bisector of this particular angle. Okay, that's why I have directly used that property. So it means this angle and this angle are equal. I can name them as angle Y and angle Y. Okay, these two angles are angle Y and angle Y. After this, you can see that angle AED is equals to angle CEB. Angle AED means this angle and CEB means this angle. These two angles are equal. Why these two angles are equal? Because they are vertically opposite angles. Okay, why they are vertically opposite angles? Because this CD is a straight line, this AB is a straight line, and what is point E? Point E is the intersection of AB and CD. That's why I can say this particular angle and this particular angle are equal, that is vertically opposite angles. So can I name them as Z and Z? Okay, मैंने इन दोनों angles को Z और Z नाम दे दिया. Now you can see that this is a complete angle. You can see that this is a complete angle. This is a complete angle. So it means angle X plus Z plus Y plus Y plus Z plus X, this must be equal to 360 degrees. What I can say is X plus Z plus Y plus Y plus Z plus X is equals to 360 degrees. Why this is 360? Because it is a complete angle. It's a complete angle. So it means 2 times of X plus Y plus Z is equals to 360 degrees, which implies X plus Y plus Z is equals to 180 degrees. This is the condition. Now try to understand, try to interpret this condition. So it says X plus Y plus Z is equals to 180. It means X plus Y plus Z stands for these three angles, X, Y and this X, Z and Y, these three angles. The sum of these three angles is equals to 180 degree. What does it mean? It means that this OEE dash is a straight line, because this complete angle is equal to 180 degrees. So I can say X plus Y plus Z is equals to 180 implies that OEO dash is a straight line. Okay, it's a straight line. That's why this angle is 180 degree. Now since this angle is 180, OEO dash is a straight line, it means OE and O dash all lie on a single line, all lie on the same line, that is OEO dash are collinear. Okay, after this I can write that OEO dash are collinear because this is a straight line. It's a straight line because this angle is 180 degree. Okay, so try to interpret this relation. Try to interpret this relation to get the final answer. Okay, so by this we can say OE, O dash are collinear. So this is the solution for question number 27th. We are left with 3 more questions. You can note this, then we will continue.